Graph. F of x equals 3 to the x, and g of x equals negative 3 to the x. First we'll graph this f of x function. And when x is 0, we have 3 to the 0 power, which equals 1. So this graph will cross the y-axis at y equals 1. If we plug in larger values of x, this is going to keep on going up and up and up and up and up, and so on, and so it's going to be increasing. So this blue function is increasing, or the f of x function, because as you go from left to right, it shoots up. G of x, on the other hand, if we plug in 0 for x, this is the opposite of 3 to the 0. So this is going to be the opposite of 1. Notice that the parentheses are not around the negative 3. So that means that the x, the exponent x, is just being applied to the 3, not to the negative sign. So that is why we have negative 1 here. So actually, we will have on this red function, the g of x function, we'll have a y-intercept of negative 1. And actually, that makes sense because if you think about, try to think about transformations of graphs, and this is just the opposite. G of x is just the opposite of f of x. So whatever you thought you had in blue, in red is going to be the opposite. So a mirror image across the x-axis. So this function is decreasing. Now, in textbooks and such, you will see other examples such as h of x. H of x equals 3 to the negative x. Now this negative exponent is the same as saying 1/3 to the positive x, right? Because it's kind of the same as, it's not kind of, it is the same as saying 1/3 to the positive x, which can be written as 1/3 to the x, because 1 raised to any exponent is just 1. So let's think about what happens there. If I have 1/3 to the 0 power, well, that's still going to be across the y-axis at 0, right? H of 0 equals 3 to the opposite of 0, which is just 0, which just equals 1. But what if I have negative, h of negative 1? That's 3 to the opposite of negative 1. That equals 3 to the first. So when x is negative 1, y is positive 3. And I know on these other, the blue and red graphs, I wasn't perfect on meeting the points where they should. I was really interested in that y-axis. But let's take a look at this one. It's going to be coming down, 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 and it will actually not cross the y-axis or the x-axis. It's just going to keep going up on the left. So this is another decreasing function. What's in yellow is decreasing. So that's another example of a decreasing function that you might see. This this base that is greater than 1, not a fraction, but this base that's raised to a negative exponent, or a base of a fraction raised to a positive exponent. That will be decreasing. So these are the ones. This h of x is something that is a little bit, I'll say, less intuitive, or you have to think about it a little bit more, maybe plug in some numbers. This 3 to the x, it's a little more natural for us to just think 3 raised to an exponent, it gets bigger and bigger and bigger. But when you have a fraction, and let's do that. Let's say h of positive 1 equals 1/3 to the first power. So that's just 1/3, and we see that happening. It's dropping down and down. And if I had plugged in 2 for x, I'd have 1/3 to the second power, or 3 to the negative 2, which is the same as 1/3 to the second power. So that's just a little bit of information on increasing and decreasing functions, specifically exponential functions.